Now let's continue solving right triangles, looking at problems where we need to solve for the angle. So again, what we're going to remember is we're going to use SOHCAHTOA, sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And we're going to use this to solve for angles or sides of right triangles. In this case, we're going to try to solve for the angles. And the thing to remember is that the opposite and adjacent switch depending on which angle you're talking about. So this is, in a right triangle, this is clearly the hypotenuse because it's across from the right angle. Now, depending on what angle you're looking at, the adjacent, the hypotenuse, the adjacent and the opposite switch, if this is the angle that you're looking at here, this is the adjacent side because it's adjacent to the angle, and this is the opposite side. So let's look at a problem. Let's solve for alpha in this problem. Let's say this is alpha, and this is 19, and that side is 7. So the first thing you need to do is decide if you're going to use sine, cosine, or tangent. Since it's a right triangle, you know it's a SOHCAHTOA problem. So in this case, if this is the angle we're interested in, this is called the opposite side, and this is the adjacent, AH. SOHCAHTOA. Since it's the adjacent and hypotenuse, since it's the opposite and the hypotenuse, right? Opposite, hypotenuse, then we're going to use sine. So we're going to go sine theta is equal to opposite over hypotenuse. I always write this problem, part of the problem down. We know in this case it's 7 divided by 19, and we get sine of theta is equal to 7 over 19. Now this is sine. This is if we're given the angle. We're not given the angle here. We want to find out the angle. So we actually want to go backwards here. And the way that we go backwards when we're doing a sine, cosine, or tangent problem is we use the inverse trig functions. In this case, sine inverse of 7 over 19 is equal to theta, or in this case, alpha. That's what we're solving for. And the sine, every calculator is going to be somewhat different, but here on this particular calculator, sine inverse is above the sine, it's a shift, and that's generally the way it's going to be. So I'm going to go sine inverse, and then I'm going to go 7 divided by 19. And I get 21.7 degrees approximately. You might want to check to make sure that you're on degrees. The way that I check to see if I'm degrees is I just go tan of 45. I memorized that the tan of 45 is 1. If I get 1, it's in degrees. In this case, it is. So then alpha is equal to 21.7 degrees. Let's look at another problem. Now let's find all angles. Find x and y if you're given this triangle. Let's say this is x and this is y. Let's say this is 10 and this is 16. Now the trick here is it doesn't matter whether you solve for x or y first, but depending on which one you're going to solve for, you're going to use different trig functions. So in this case, let me try to solve for x first. In this case, I have the opposite and I have the adjacent. So if I go tan x is equal to opposite over adjacent, I have to be careful which is which. If this is the angle I'm interested in, x, this is the adjacent, that being next to, and this is the opposite there. So this is going to be tan of x is equal to 16. 16 opposite over 10 adjacent. Since I'm finding x, I do the inverse. I go tan inverse of 16 over 10 is equal to x, and I just do that on my calculator. I go tan inverse 16 divided by 10. And I get about 58 degrees. It's 57.995. Depending on where I'm rounding to, if I round to one decimal place, that's going to be 58 degrees. Now, alternatively, I could have solved for using y. I could have gone tan of y. It's also equal to opposite over adjacent, right? But the opposite and adjacent switch now. The opposite of y is going to be 10, and the adjacent is going to be 16. And then I go tan inverse of 10/16 is going to be about 32 degrees. It turns out I don't need to do it both ways. Let's say I solve for x is equal to 58. I already know that I have a right triangle, so if x is 58 and the other angle is 90 degrees, then I know that whatever I have to add up to has to equal to 180. 90 and 58, 148. The other angle has to be 32, so it wouldn't matter. Now let's find the angle in degrees. I'm sorry, let's find the angle in radians. And it turns out that the only difference there is that you're going to change the set on your calculator. So again, if this is the angle I'm interested in, this is the opposite, and this is the hypotenuse, OH, so katoa. So opposite over hypotenuse is sine, so I'm going to go sine theta is equal to opposite over hypotenuse. I'll plug in whatever I know. Sine of alpha, alpha is what I want to know, opposite 9 over 15. So I'll go sine inverse of 9/15. But I want it in radians, so what I need to do is first check to see what it's in. If I go tan of 45, I know that's equal to 1, so that's in degrees, so I have to figure out where it's at. It varies by calculator. You might have to go to mode, or you might have to go to degrees or radians. This one has DRG. Look at DRG, if I push that button, I have degrees, radians, and gradients. If I just push the cursor over to radians and hit enter. Now let's go tan of 45 to see if that worked. Tan of 45 here is 1.619. If you go tan of 45 equal to 1, you know it's degrees. Otherwise it's not. Now it's in radians. So then I just go sine inverse. Sine inverse. 9 divided by 15. And I get 0.644 radians. And that's how you do trig using SOHCAHTOA when you need to find the angles.